expressions and quadratic equations. So in this part of the packet, we're starting with naming the polynomials. So polynomials have two different ways of naming them. One is by how many terms they have, and the other is by the degree. Remember, a term is just a part of the polynomial that's separated by adding or subtracting. So this is a term and this is a term, separated by that minus sign. In order to find the degree, we have to look at the highest power on one of these terms. So this has a power of 4, this has a power of 2. Because the 4 is the bigger power, we say that this is a 4th degree polynomial. But specifically, because it has 2 terms, we say that it's a 4th degree binomial. And bi means 2, like bicycle has 2 wheels. This one, again, we look at the terms. Here's a term, here's a term, here's a term. Each of them are separated by plus or minus. And we're looking for the degree, so we look for the highest power. This has a phantom power of 1. This has a power of 2. This doesn't have any variable, so this is a power of 0. So 2 is our highest power. And instead of just saying second degree, we have a fancy word for that. We call it quadratic. And we talk about quadratics a lot. So this is a quadratic, and because it has 1, 2, 3 terms, that makes it a trinomial, like a tricycle that has 3 wheels. Number 72 here, again, terms are separated by plus or minus. This has multiple parts to it, but there's no plus and there's no minus, so technically this is all one big term. It just happens to be a term that has 2 different variables in it being multiplied. To find the power here, or the degree here, we're actually going to add together the powers. So there's 2 of the p's and 3 of the w's. All combined, this makes it a degree 5. So we're going to say this is a 5th degree polynomial. And specifically because it has 1 term, this is a monomial. Kind of like how a monocle is like glasses, but it only has 1 lens. All right, simplify each expression. So really what this is telling us to do is to add or to subtract the polynomials. And this really just comes down to combining like terms. With adding, we have these parentheses here, but they really don't do anything. It's just telling us to take all 6 terms here and add them together. We're going to combine the like terms. So if I have x squared here, I need to look for any other x squareds that it could combine with. And I see one of those right here. I see 4x squared. So 3x squared plus 4x squared, when you combine like terms, it's still just x squared, but you add the coefficients. So 3 of them plus 4 of them gives us 7 of them. Then I can look at the 3x. Maybe I'll cross out the ones I've already used. That might help us keep track. 3x can combine with x. So there's a phantom 1 here. If I have 3 of them plus 1 of them, that means that I have 4 x's. And again, I could cross them out once I'm done with them. And then I have a 4 and a negative 7. Combined, those just make minus 3. Okay, next problem. I have m cubed, and I'm looking for other cubes that it could combine with, and I don't see any. So it can't combine with anything, it's just m cubed. Minus 4m squared, plus over here there's a negative 3m squared. Because those are both m squared, they can combine. Negative 4 and negative 3 make minus 7m squared. I could go to the 6, but first I see over here just a plain m, so I'm going from m squared now to m. This one doesn't have anything to combine with, so that's just plus m. And again, maybe I'll cross out the ones I've already dealt with. And so what's left is just the numbers 6 and 8, which add together to make 14. All right, next up down here, I want you to notice now we're subtracting. So before we were adding polynomials, now we're subtracting. When you subtract, the parentheses do matter. We're subtracting all of this, which basically means everything inside this set of parentheses gets flipped. The first set of parentheses stays the same, so we still have 2y squared plus 5y cubed minus y, but then this becomes minus 8y squared, and then the minus here flips this to become plus 9y. It's almost like distributing the negative. In fact, that's exactly what we're doing because it's like a phantom -1 that's being distributed. Now I can do my combining like terms. 2y squared minus 8y squared is -6y squared. I can cross those out. And then, this 5y cubed is actually a bigger power. Let me put it before. It doesn't have anything to combine with, so we'll start with the 5y cubed minus 6y squared. And then I've got minus y plus 9y, which is plus 8y. So there's my final answer. For this one, 8x squared plus x plus 9 minus, so again we're subtracting, which means all these are going to flip. So 8x squared plus x plus 9 minus x, and then this distributes and flips to become plus 5x, and then plus 2. So all these ones get flipped. The x squared, 8x squared, doesn't have anything to combine with, so it just stays. But now I have x minus x plus 5x. So there's a lot going on there. The plus 1x, the minus 1x cancel each other out, and then I just have plus 5x. So I've taken care of all of these. Plus 9 plus 2 is plus 11. Last one. Ooh boy, they gave us a lot of stuff to combine. Again, this one is a plus, so we can basically just ignore the parentheses and combine like terms. The trick is going to be looking for all the like terms. I see xy to the fourth and xy to the fourth, so I think those can combine. This is negative, which is really like a phantom -1. So if I have -1 of these plus 4 of these, that's 3xy to the fourth. Then I've got 5xy cubed minus 5xy cubed. So if I take this, and maybe I'll cross out the ones I'm done with, these two can combine, but look, if I have positive 5 minus 5, I just get 0. These cancel themselves out. I could write 0xy cubed, but it just disappears. 2xy, let's see, I don't think it has any friends. I don't think it has anything to combine with, so we can just put plus 2xy. We're done with that one. Minus x squared y squared, and then over here I see plus 2x squared y squared. So this and this can combine. There's a phantom 1 here, so minus 1 plus 2 becomes plus phantom 1 x squared y squared. So we're done with these. And what we're left with is just x cubed y. All right, those are all the parts. If you look in the answer key, it says something a tiny bit different. It's sort of impolite to leave the smaller powers here and keep like the bigger powers at the end. So typically we sort of arrange it so that the big powers come first. So the answer key says 3xy to the fourth plus x cubed y plus x squared y squared plus 2xy, because we're just rearranging these. This stayed in the same place. This one moved to the end. This one stayed in the same place. This one moved towards the beginning. So we just rearranged them. I don't think it's super important. I mean, it's mathematically the same if you write it this way, but it's more common to write it this way, and it's sort of convenient for certain types of math if you can put it in the right order. But on the test, as long as you can choose the correct answer choice on a multiple choice test, you're good to go. So as long as you can recognize that these are the same, you're good. All right, all of these problems say find the product. Product means we're multiplying. So it's this polynomial times that polynomial. And as you're getting ready for the test, the most important thing to remember is that multiplying means, well, there's a couple of strategies. I really like the box. I'm a big fan of just setting up a box and multiplying that way. There is like FOIL as well, or you can call it double distribution. But I just like to take 5x minus 6 and 2x plus 3 and set up because there's 2 terms here and 2 terms here, a little 2 by 2 box. 5x minus 6 I'll put on one side. 2x and 3 I'll put on the other side. And then the box helps me multiply each pair. So 5x times 2x is going to go in this top left box. Now remember, the big numbers multiply, so 5 times 2 is 10. Then I have x times x, which is x squared. Now in this top right box, I'm doing the 5x times 3. So 5 times 3 is 15. And then there's one single x with nothing else to multiply with, so it's just an x. Bottom left is negative 6 times 2x, which is negative 12x. Multiply the coefficients, the x just is along for the ride. Negative 6 times 3 is negative 18. And now in order to get the final answer, I need to take these 4 terms and just write them out. So 10x squared plus 15x minus 12x minus 18. But we have 2 like terms here, the plus 15x and the minus 12x, which as you become an expert at this, you start to recognize the pattern that right in the box, typically they end up diagonal like this. These things can combine. So 10x squared stays the same, but 15 minus 12 just gives me plus 3x and then minus 18. So this is my final answer for multiplying these 2 polynomials. All right, next one is right here. Again, I'm going to set up the box. So I'm going to do x minus 5 times x minus 6. This gives me x squared minus 6x minus 5x, and then negative 6 times negative 5 gives me positive 30. Again, I can combine like terms here, so these can go together, which means I have x squared. Negative 6x minus 5x make negative 11x, and then plus 30. And so this is my final answer for this one. You can keep doing the box for all of these, but I want to show one other way if you're a fan of this method. Some people learned the FOIL method. FOIL means, it's an acronym, right? First, outside, inside, last. So first means take the first term of this one and the first term of this one and multiply them together. 2x times 5x is 10x squared. O means outside, so it's the outside edges, which is way on the left and way on the right. I've got 2x times 1, which is just 2x. I means inside, so towards the middle. I have negative 6 times 5x, which is negative 30x. And then L stands for last, so the negative 6 times 1 is negative 6. And then just like with the other ones, we can combine like terms. So we get 10x squared minus 28x minus 6. You could have done the box for this one and you'd get the same answer. It's just a different strategy. You can pick whichever strategy you like better. All right, this one. Again, you can do the box here, but because there's only one term, it's not parentheses, it's just one thing, you would do a little mini 1 by 2 box. So you would say 3x squared times 2x minus 9. 3 times 2 is 6. Ooh, x squared times x. This has a phantom 1. If I have x squared times x, there's 2 x's here and 1 x here, which gives me x to the third. So remember the powers add. And then here, 3x squared times negative 9. Well, 3 times negative 9 is negative 27 x squared. And so my answer is just 6x cubed minus 27x squared. You didn't have to do the box though. If you want, you can just distribute this and it gives you the exact same thing. You multiply here and get 6x cubed, multiply here, get negative 27x squared. Down here, this one looks a little different because it's x minus 5 squared. But I want you to remember what squared means, right? If you square something, that really just means multiply it by itself. So this is just x minus 5 times x minus 5. And if you have that, now it's the same as always. I'm going to do a box again, so x minus 5 times x minus 5, x squared, right here is minus 5x, this is also minus 5x, and this is plus 25. Negative times negative is positive. These like terms can combine, and so I end up with x squared, and then these combine to make minus 10x plus 25. And for the last one, similar situation, it's squared, so this is really just 3x plus 2 times 3x plus 2. If I make a box for this one, 3x plus 2 times 3x plus 2, these multiply to make 9x squared, these multiply to make 6x, these also multiply to make 6x, and these multiply to make 4. Last one of these, I can combine like terms. So I get 9x squared, these make, I'm adding them, so they get 12x, and then plus 4. Just like that. All right, first page done. On to the next. Okay, now this page, instead of multiplying, is all about factoring. And factoring is kind of like the opposite of multiplying. It's like taking, if you were going to factor a number, it's like taking a number and working backwards to figure out what's the multiplication problem that can give you that number, right? That's what factoring is. So in this case, this is like the answer to a polynomial multiplication problem, and it's asking me, what two things can I multiply to give me that answer? Well, we have a process for factoring this directly, like if it's a free response question, but I'll let you in on a little secret, which is if it's multiple choice, you can also just use your multiplication skills, right? If you know how to multiply, you could look at A and say, well, let me check if A is correct, right? Let's see if I multiply this times this, do I get that? All right, so we're gonna check A here. Let's just try multiplying x minus 2 times x plus 6. I get x squared plus 6x minus 2x minus 12. Well, this gives me x squared. These combine to make plus 4x, and then minus 12 at the end. So the x squared looks good, the minus 12 looks good, but the plus 4x does not match, so this is wrong. Something you might notice, you can start to see some patterns. We can go through and do a whole nother box for B, but you might start to take some shortcuts. For example, this one is x minus 3 times x plus 4. You might say, okay, let me do the bottom right box first. Negative 3 times 4. I get negative 12. Okay, that checks out, right? That seems good. So far so good, let's keep going with this. Now maybe I'll do the whole thing. X times x is x squared. 4 times x is 4x. Negative 3 times x is negative 3x. Well, this gives me x squared. These combine to make plus 1x, and then minus 12. Oh, it's so close. X squared matches, minus 12 matches, but this is positive and I want negative. So this is wrong. But check this out. I wanted negative, but I got positive. It might make sense to check out answer D, because answer D is like the same thing, but the positives and negatives are flipped around. So let's check that one. If I go to D, let's see if D is correct. So, box method, I have x minus 4 times x plus 3. This is x squared. I'm going to jump around a little bit. This is negative 12. X squared and negative 12. Okay, those look right. Now, x times 3 is 3x. Negative 4 times x is negative 4x. This gives me x squared. And then these combine to make minus 1x minus 12. That's exactly what I wanted. So D is the correct answer. The more you do this, the more you're going to start to see little shortcuts and see ways that you can make your life easier. You might even be able to do some stuff in your head where you say like, hey, negative 2 times 6 is negative 12. Negative 3 times 4 is negative 12. You can sort of check those things really quickly without even needing to set up a box. And you might be able to eliminate some faster. However, you could have a free response problem like this where you need to actually do the factoring yourself. It's not common, right? Typically it's a multiple choice problem. You can do our trick up here, but I'll show you the factoring process if you have to do it yourself. It's a little bit long. It's a little bit tedious. On a test, if you could do it this way, I would recommend doing it this way, but let's talk about the long process just in case. There's a bunch of steps here. Step number 1, always, is to multiply the first number times the last number. So in this case, 2 times negative 12 is negative 24. The second step is always to take that product, negative 24, and find other multiplication facts that give you the same thing. So you're going to think about, well, what else can I multiply? I can do 1 times negative 24 to get negative 24, 2 times negative 12, 3 times negative 8, 4 times negative 6, 5 doesn't work. I can do 6 times negative 4, or 7 doesn't work, 8 times negative 3, 9 doesn't work, 10 doesn't work, 11 doesn't work, 12 times negative 2, and then you might see the pattern here, 24 times negative 1. These columns end up being opposites of each other. Now, my next step, and this process has a lot of steps to it, my next step is to figure out of these pairs, I was in multiplying mode, now I'm going to switch my brain to adding mode. So thinking about these as pluses and saying, okay, if I'm in adding mode, which pair adds to make negative 5, the middle number? Well, let's see. This one doesn't. This one doesn't. Ooh, 3 plus negative 8 makes negative 5. Be careful, you don't want to choose 8 plus negative 3 because that makes positive 5, so you got to be careful about that. None of these work except for this one. Okay, the fancy next trick then is to split the middle. So this negative 5x, we can use the pair we found to break it apart. So we're going to take 2x squared. The minus 5x is going to change. Over at the end, we are still going to have the minus 12. But in the middle, this minus 12x is going to split into two things. It's going to split, based on these numbers we chose, into 3x minus 8x. It's kind of like the opposite of combining like terms, right? We could combine these to make negative 5. We did the opposite. We took negative 5 and we split it apart based on the pair that we chose. All right, now you're going to group together in your brain the first two terms and the last two terms. You're going to take the first two terms, we're going to start with those. You're going to look at the coefficients 2 and 3. And you're going to say, is there any number that 2 can be divided by that 3 can also be divided by? Well, 2, you can't divide it by very much stuff. You can divide it by 1 or you can divide it by 2. 3 is similar. You can divide it by 1 or you can divide it by 3. The only thing they have in common is 1. So I'm going to pull a 1 out. And then both of these have at least one x, so I'm going to pull an x out. On problems like this, you always have an x in this position. Now I'm going to put parentheses and sort of deal with all my leftovers. So I want 2x squared, but I have 1x. So I'm trying to figure out, what can I multiply 1x by to get 2x squared? Well, I need to multiply it by 2, because 1 times 2 is 2. And I need to multiply it by x, because x times x is x squared. So this is like the opposite of distribution. Then I want to do 1x times something gives me 3x. Well, 1 times 3 is 3, and x I already have, so I'm good. So you can now notice if I do 1x and I distribute it, I get 2x squared plus 3x. So I'm like reverse distributing. Similar kind of thing here. I'm going to look at the negative 8 and the negative 12 and think about what can they both be divided by. Well, I'm noticing that both of them are negative, so they can both be divided by a negative number, and I'm seeing that they can both be divided by, well, 2. They can both be divided by 2, but there's a bigger one. They can both be divided by 4. So the 8 and the 12 can both be divided by 4. That's the biggest thing. And because they're both negative, I'm going to say negative 4. All right, it's parentheses time. Negative 4 times something gives me negative 8x. I need to multiply by 2, and I need to multiply by x. Negative 4 times 2x is negative 8x. and then I need negative 4 times something is negative 12. I think that something could be 3, because negative 4 times 3 is negative 12. Now notice, this should always happen. 2x plus 3 and 2x plus 3 match each other. If you did it right, if you picked the right pair over here, that should happen every single time. And what that means is we can just take the outside bits, so the 1x minus 4, and we can put them in parentheses. And then we can take the 2x plus 3 that shows up twice and put that in parentheses. And that gives us our final answer. Technically, the 1 is a phantom 1, so we can get rid of it. Our answer is just x minus 4 times 2x plus 3. If you look at the answer key, they write it the other way. They do 2x plus 3 times x minus 4. That's okay. That means the same thing. They just flipped the multiplication around. If you wanted to get something like this, you would do, when you split the middle, 2x squared minus 8x plus 3x minus 12. You just flip the order of those, you get the same thing. So your process would be different, but you'd end up with effectively the same answer. All right, back to 86. This process was long, right? I could use this process again to factor this thing, but man, I really don't want to. So instead, I'm going to do what we did on 84 and just basically try all the multiplications. Now, we already did the long way here of just trying all the multiplications with the box, and you could do that again here. So you could set up a box for A, set up a box for B, set up a box for C, set up a box for D. There are some shortcuts, although they purposely chose tricky answer choices here. One of the shortcuts is you can multiply the first times the first and make sure that you get 3x squared, which in this case we do. 3x times x is 3x squared. 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 Okay, we can't eliminate any of them because it worked for every single one. We can also do the last number times the last number. So 1 times negative 5 gives us negative 5. Negative 5 times 1 gives us negative 5. Negative 1 times 5 gives us negative 5. 5 times negative 1 gives us negative 5. Man, they chose tricky answer choices, right? If any of those didn't match, we could have eliminated them, but too bad, so sad. It's box time. So we can check A. So I'm going to do A. I'm going to say, all right, 3x plus 1 times x minus 5. That gives me 3x squared. This gives me negative 15x. This gives me 1x, and this gives me negative 5. 1x and negative 15x make negative 14x. I wanted 2x, so that's wrong. All right, let's try B. Now, we already checked the 3x squared and the minus 5 for all of these. So how about this? Let's do 3x minus 5 times x plus 1. So I'm checking B. But let's just do this diagonal to save ourselves some time. So 3x times 1 is 3x. Negative 5 times x is negative 5x. These make negative 2x. Ooh, it's so close, but I want positive 2x, so B is wrong. Okay, let's try C. C is 3x minus 1 times x plus 5. This gives me 3x squared, 15x, negative 1x, negative 5. If I look at these, 15 minus 1 is 14x, but I wanted 2. No good. By process of elimination, D should be correct, but let's just check it real quick to make sure we're right. 3x plus 5 times x minus 1. And again, I know that I already checked this and this earlier when we were doing our shortcut check. So let's just do the diagonal. 3x times negative 1 is negative 3x. 5 times x is 5x. Does this make positive 2x? Yes, it does. So D is correct. These problems take a while, don't they? I mean, I really don't know what to tell you. They're a little bit long. But let's see if we can find more shortcuts here. 87A. Again, I'm trying to make this. Well, most of them have a 2 out front. Let's see, if I multiply this, A gives me y minus 12 times y minus 3 Don't forget though, there's a times 2 out front. So this gives me y squared minus 3y minus 12y and then plus 36. So this becomes y squared. These combine to make minus 15y plus 36. But we can't forget about the 2. There's a times 2 out front, so everything multiplies by 2. So this is really 2 times all this. So I get 2y squared minus 30y plus 2 times that is 72. All right, the 2y squared worked, the 72 worked, this did not. So A is wrong. You can keep going through these, right? It takes a while. Let's try B. I have y plus 9 times y plus 4, y squared plus 4y plus 9y plus 36 again. Okay, so this is y squared plus these combine to make 13y plus 36. And again, it's multiplied by 2 out front, so all of this is times 2. So I get 2y squared plus 26y plus 72, and oh, thank goodness, I got what I wanted. So B is correct. If you had all the time in the world, you could check C and D to make sure they're wrong, but man, on an exam, you really don't always have all the time in the world, so maybe we call it good there. 88 is the long factoring process again, just like 85. I'm going to go through it a little faster this time, but it's going to be the same process. First number times last number. So 3 times 15 is 45. I had to think about that one for a second. I'm just going to separate out our space here. I'm going to take 45 and figure out all the things that multiply to 45. So I see 1 times 45, 2 doesn't work, 3 times 15 is the one we just did, 4 doesn't work, 5 times 9 works, 6 does not, 7 does not, 8 does not. If you're ever not sure, you can try dividing. So you can say 45, okay, divided by 1, 45 divided by 2, no good, 45 divided by 3 is 15, 45 divided by 4, 45 divided by 5 is 9, so it can kind of help you make the list. And then, let's see, 45 divided by, wait, no, 6 doesn't work, 7 doesn't work, 8 doesn't work, but 9 does, okay. Well, I can also do negatives. That's another option. So I could do, if I want to make 45, -1 times -45, or -3 times -15, or -5 times -9. I'm looking for one that adds to make -9. I don't see any. I don't see any that add to make -9. Well, this one's actually a little bit evil. This problem's a little bit mean. There are no pairs, if I add them together, that make -9. Absolutely none. So I actually can't factor this the same way I did up here. I'm just stuck. So instead, the only thing I can do is actually similar to this step where I pulled out the greatest common factor. So we have to give up on this and say, okay, 3x squared minus 9x plus 15. What can all of these numbers be divided by? Well, they can all be divided by 3. So I can pull a 3 out of here. So 3 times x squared minus 3x plus 5 gives me this. It's just the reverse of distributing, and this is all I can do. I have to give up at this point because I didn't have a better option here. All right, number 89, x squared minus 100. This year I did not teach this because I don't think it comes up very often. It's not very important, but for future reference, this is a difference of squares where we're subtracting 2 square things. These kind of problems always end up with a plus and a minus being multiplied together, where you divide the power in half. So 2 divided by 2 is 1, and you square root the numbers. They flipped it around, but it's this one. There's a couple more difference of squares problems here. I'm not going to worry about this. I'm not going to worry about this. I'm not going to worry about this. Instead, I want to focus on the solve by factoring. Again, solving by factoring is different than how I taught it to my class this year. It's kind of a shortcut. If you're watching the year that I'm recording this, I would just do quadratic formula for these problems. So I would take this and do quadratic formula, or I would take this and subtract 15 from both sides to make it equal to 0, and then do quadratic formula. But we can solve by factoring. The trick here is to find two numbers that multiply to 6 and add to 5. Those two numbers in this case are 2 and 3. So we can turn this into x plus 2 times x plus 3 equals 0. And again, if you think about the box, if you multiply these, you end up getting this. And then to solve by factoring, we just say, well, I want the overall thing to equal 0. So I just need to make one of the individual parts equal 0. I can make the first part equal 0 by doing x equals negative 2. I can make the second part equal 0 by doing x equals negative 3. That's pretty quick. If you don't like the solve by factoring, the alternative is quadratic formula. Over here, similar thing. I'm looking for two numbers that multiply to make negative 15, add to make negative 2. You can go through your list in your head and try to figure out what it is. Maybe I'm looking for things that multiply to make negative 15. And as I go through my list here, negative 3 times 5 feels close, but it's not quite. How about negative 5 times 3? Negative 5 plus 3 gives me negative 2. So I'm going to do x minus 5 times x plus 3. And then I can solve this by making x equal to positive 5, because that makes it equal 0, or x equal negative 3, because that makes this equal 0. Again, if you do quadratic formula, you get the same answers. Here's a quadratic formula question. Quadratic formula asks us to identify the three different parts of the quadratic. We call them a, b, and c. A is the coefficient in front of x squared, which in this case is 1. So a is equal to 1. B is the coefficient in front of x, which is also a phantom 1. So b equals 1. C is just the plain number, so c is negative 3. And then the quadratic formula, you do need to have this memorized, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So now I can plug in my a, b, and c. b is 1, so it's going to become negative 1, plus or minus the square root of b squared means 1 squared, minus 4 times a, which is 1, times c, which is negative 3, divided by 2a, which is 2 times 1. All right, this can simplify. Inside the square root is where I'm going to focus my attention first. 1 squared is 1. Now I've got negative 4 times 1 times negative 3. The negative times negative is actually going to give me a positive. So negative 4 times 1 times, whoops, typo. Negative 4 times 1 times negative 3 is positive 12. So this becomes plus 12. All divided by 2 times 1, which is 2. All right, the next step is not so bad. What's 1 plus 12? Well, that's just 13. Everything else stays the same. And at this point, square root of 13 is really ugly. I can't really do anything with the square root of 13. It's irrational. So I'm just going to look at my answer choices. I wrote it as plus or minus. They wrote it out as two separate options, but I'm looking for negative 1. Here's positive 1, no good. Positive 1, no good. Negative 1, I'm happy. And then square root of 13. This one looks good to me. This does not. So they just took the plus or the minus and wrote it out once with a plus, once with a minus. Almost done here. On to the last problem of this section. Again, it's a quadratic formula problem. So I'm going to identify my A, my B, and my C. A is equal to -2, because it's the coefficient in front of the x squared. B is equal to 5, because it's the coefficient in front of x. C is equal to 6, because it's the plane number. My quadratic formula, same as before, -b plus or minus square root of b squared minus 4ac over 2a. I plug things in. -b means -5 plus or minus square root of b squared means 5 squared minus 4 times a, which is -2, times c, which is 6. Oh, I'm running out of space. All over 2 times a, which is -2. All right, let me move to the left so I have room. -5 stays the same, plus or minus square root of 5 squared is 25. -4 times -2 times 6. Let's see, -4 times -2 times 6 is positive 48. So plus 48. Divided by 2 times -2 is -4. All right. I always like this step where I just have to add or subtract two numbers together. I can do that. 25 plus 48 is 73. Divided by -4. Now, on this one, square root of 73 is really ugly again. I don't like that number very much. It's irrational. But they don't let me just leave it as square root of 73. They're looking for a decimal approximate answer. So in order to get that decimal approximate answer, I'm just going to use an approximate decimal. If I split this apart, the plus and the minus, there's two different ways this could go. I could have -5 plus, and then square root of 73 is 8.54 divided by -4. Or I could have -5 minus 8.54 divided by -4. I just wrote on my table. -5 plus 8.54 is 3.54 divided by -4, which is equal to -0.88, or really 89, I guess, if I'm rounding correctly. This is -5 minus 8.54, and then divided by -4, which is 3.385. Let's see. This doesn't exactly match my answers, but -0.89, someone could reasonably round that to -0.9. 3.38 could be 3.4. So A is correct. Give yourself a pat on the back. That's another section done.